Alright, so let's start our sixth mini project, which is on car and pedestrian detection. So let's take a look at the code and see how we implement this. Alright, so let's go ahead and open our sixth mini project. That's lecture 6.3. And here we go. So I actually want you to run a test. Just make sure OpenCV is installed properly on your machine, because there's a very common issue that prevents OpenCV from actually playing videos. So let's run the code, and this is how it's supposed to work. So that's actually our pedestrian detection going on right there. So let's close it off, and now if nothing happened, if this code ran and executed successfully, however it didn't load any video and didn't even throw an error, that means that your paths for this file, OpenCV ffmpeg DLL, hasn't been found. So what you'll need to do now, you'll need to actually find where this file is. It's stored in your OpenCV directory, so let's just get it here. So this is where OpenCV is installed in my machine. Just rename the directory here. So go to OpenCV, go to sources, go to third party, ffmpeg, and this is the file here that we're actually going to copy. So we actually copy that file to where your Python is installed. So this is where my Python is installed, in Anaconda 2 apparently. So to find the directory Python is installed in your machine, just run these two lines of code and it tells you where the Python exe is stored. So what you need to do, you need to drag or copy this file to this Anaconda 2 directory. At least that's in my machine where it's installed. So let's quickly do that. So I'm in the base directory where my Python exe is installed, and you can see I have the files here. However, there's one important thing to note. You are going to have to rename the file. So I've just kept the original here, and you can just make a copy of it and rename that copy with the version of OpenCV that you're currently using. So I'm using 2.413. So that's a version I've called here in the name. So similarly, if you're using 3.1, you can just put 310, no decimal points either, and underscore 64 if you're using a 64-bit machine. If not, if you're using an x86 32-bit machine, which most of you shouldn't be, you just leave out the underscore 64. Okay, so that's it. So once you've done that successfully, and the instructions are here in case you didn't follow it properly in my video, you can just execute it and try this again, and hopefully it should work. So now let's go about explaining what this code is doing here. So this code is actually pretty simple, and it follows a similar method that we have actually just done for face and eye classification. So we're using a different classifier now. This is a full body classifier, and this is what we're using to basically classify pedestrians. So let's create our body classifier object, and what we're doing differently here though is that instead of actually having this argument as 0 as we did for video capture with our webcam, we're actually pointing it to an AVI file. That's the walking file. That's a file with the pedestrians walking. It's actually a standard file that's actually used in a lot of research, so it's why I'm using it here for you guys. So again, while a cap is opened, or you can have while true and have a break statement here. It's up to you. We're reading each frame of our video file here, and we're also resizing the frame to half its size. And the only reason we're doing that is actually to speed up our classification method, because larger images obviously have a lot more windows to slide over, or a lot more pixels I should say, to slide over. So it's actually going to slow it down quite a bit. So we're decreasing the resolution of that video by half. That's what the 0.5 indicates here. And also using one of the quicker interpolation methods, interlinear. Okay, so then we also have to grayscale our image as we had done previously. And we feed that image into our detect multiscale, which is our classifier, and set our parameters here. And as you remember, this was a scaling parameter. Larger values makes the detection faster, I should say. And this value is basically a sensitivity factor. So by reducing it, it actually becomes more sensitive, but it also produces a lot of false positives. So these parameters work well, and you'll see shortly. And what it does, again, it returns bodies being an array of points, and then we can actually just plot those points here using our CV2 rectangle function. So this is how we actually draw the little boxes around our pedestrians that we've identified. And we just exit this loop here by pressing enter key. So let's run this and quickly look at it. So let's bring it up. And there we go. We see it's actually detecting most of the pedestrians here. Sometimes it misses it, sometimes it doesn't, but it's actually fairly accurate and fairly good. Okay, so let's move on to car detection now. So this code actually is pretty much very similar to the previous code. The only difference is here is that we're pointing it now to our car classifier here. And pretty much the same thing is going on here. So let's just run this code and let's take a look at what's going on. So again, we see it's actually pretty accurate. It's actually picking up a lot of the cars. It's not always very accurate, especially with cars in the distance here and Mr. Truck and also Mr. Bicyclist here. But it's pretty good. So I encourage you again to play with these parameters, see if there's another one, any other better options you can have here. So line here, maybe I was experimenting with some parameters. You can delete it for this purposes here. You also may have noticed I actually have this time comment .sleep commented out here. Now what this does actually, you may have noticed that the frame rate in these videos is a bit fast. So what time does, it's a way just to add some pauses in our code. So you need to import time, and let's actually execute it here. So this with 0.1 adds a delay of 0.1 before executing the rest of the code. So you can see, yeah, it's definitely much slower. You can actually use this for testing if you want to just make sure you're testing it correctly and getting all the cars you want to see. By making it smaller, just in case you're wondering, it actually speeds up the frame rate. Type this wrong. So there we go. You can keep experimenting with it to actually get a more natural frame rate or something you like. So that's it for car and pedestrian detection. These are actually pretty simple. So I hope you actually find this stuff useful, and maybe later on in the course I can add a lecture on how to actually create these cascade classifiers. Okay, thanks.